y-axis. And on your graph paper, I expect you to use the blocks and not make your own tick marks. Okay?
Well, I gotta be tick.
I don't know where that term comes from, to be honest. I really don't. Probably from the tick-tock of the clock, because they look like the marks on a second hand of the clock. Yeah.
I was on the x-axis.
I use 10. Let me label these points. So this is the point 10, 0. This is my point 8, 0. You know what? Yeah, actually I'll do that one in the color of the line. This is my point 0, 5. And then for the other line, pass through 0, 8 on the y-axis, 8, 0 on the x-axis, and I forgot to label it. It's the point x plus y equals 8. Okay? So that's my graph. So I've done part 1 of this problem. Okay? Now I've got to do parts 2 and 3. Jen, you might want to move closer for this one, so I don't want to have to erase anything yet. I'd like to do it over here. You guys all see over here? Stop. Don't get distracted. Stop. Nope, I'm doing all 3 for this one, okay? Alright, now, substitution. 2. Okay? Substitution is the method where you get a variable by itself. And you actually have 4 choices the moment you look at a problem like this. You can get, take them off, Nick. You can get, they're distracting me. This x, this 2y, this x, or this y by itself. Sometimes it doesn't matter which, sometimes it's really obvious which way is easiest. Okay? Pick a variable to get by itself. Tell me which variable and in which equation. Jordan. Which equation, first or second? Second. Actually, the answer's either, but this one works. Okay. I'm going to go to the second equation, x plus y equals 8. I'm going to get x by itself. Somebody other than Jordan. How am I going to do that? Nick?
Subtract 8.
Nope, subtracting 8 will leave me with 0 over here and everything over here. So, Jen?
What you do is you subtract y from both sides, and that's going to equal x equals 8 minus y.
8 minus y. Brandon, good effort on the sing-along. Okay. You had already said something incorrect, and then when I went on to her, I heard you say the correct thing on the second try. No, you didn't. Yes.
Why couldn't you multiply a number?
We're going to. That's method 3, linear combinations. We're going to do that in a minute.
So what are we going now?
Substitution.
All right.
Okay, so substitution. Now I've got x by itself. There was one hard and fast rule about this. That's that once I had x by itself, when I plugged it in, I said there was one thing you had to be careful about. Jenny?
That the x had to be positive, whatever that was.
Getting the x positive makes it easier. But I said, well, now what do we do with this x equals 8 minus y?
Oh, you plug it into the other equation?
Yes, you plug it into the other equation. It has to be the other equation. You can't plug it back into the same equation. You can, but you'll get like 0 equals 0, so that's not helpful. All right, so I'm going to take this 8 minus y, and I'm going to write it in the other equation, which will get me 8 minus y plus 2y equals 10. Okay? Do I have any like terms I can combine?
Yeah.
What are they, lady?
Y plus 2y equals 1.
Well, I've got y plus 2y, but remember terms always include the sign in front of them.
Negative y plus 2y.
And what does that leave me with?
Negative 1.
Actually, it's the negative 1y plus 2y leaves me with plus 1y. Okay? And now, Nick, what do I do to get y by itself?
Subtract 8.
Subtract 8 from both sides. And then what does y equal, Brandon?
Y equals, can you just say it again real quick?
We had 8 plus y equal 10. We subtract 8 from both sides. What does y equal?
Y equals 2.
2. And y better equal 2 because I gave you the answer when we started. Okay? But now let's pretend I didn't. And now, how would I find out what x equals? Jen?
You plug 2 back into the other equation.
Either one at this point, actually. At this point, I can use either equation. When I first get x by itself,
You have to use that.
you got to jump it back into the other equation. But now I can plug 2 into either one. I think the second one's easier. I'm going to say x plus 2 equals 8. And then what does that mean x will equal?
Equals 6.
X will equal 6, so I write 6 comma 2. And that's my answer. Okay? Any questions on using substitution? What would have happened if I got an answer other than 6 comma 2?
Wrong.
Wrong. I'd go back and check it and figure out where I did it right, where I went wrong. Okay?
Wait.
Yes.
Well, x plus 2 equals 8.
Uh-huh.
And you got.
I went back up here to x plus y equals 8, and I took my 2, which I got as an answer from the first substitution, and I plugged this 2 back in for y
Right?
in my second equation. I could have done it in the other equation too.
Okay.
All right. Now number 3, the one Jordan's been chomping at the bit to solve this way. You know what chomping at the bit means, Jordan?
Like you want to do it for the 7 and not so you get.
Excellent. That's exactly right. You know where it comes from?
No idea.
Horse racing. The bit's the part that's in the horse's mouth. And when they haven't opened the gates yet, the horse really wants to run. It's chewing hard on it. It's like pulling on the bit, trying to let me run. Saying to the jockey, let me out there, coach. I'll outrun everybody. Okay.
X.
What do you want to do with this one, Jordan? You're the one who's been bugging me about this one here. So we got, this is the linear combinations. We can multiply either equation by any number you want. What's going to help us?
Multiply the second one by -1.
By -1. Okay. So I'm going to rewrite the first equation, x plus 2y equals 10. Then I'm going to rewrite the second equation as -x minus y equals -8. Have I multiplied everything correctly?
Yes.
Yep.
Okay. Now when I work out that, when I add these two equations together, what happens?
Cancel out positive 1y equals 2 positive. Positive 2.
Whoa, slow down. Yes, correct. Cancel out positive 1y equals 2. And then how do we find x?
1. Oh, plug it in.
Plug it in. Which equation? Well, I'm going to plug it into the other equation, so I plugged in that one last time. So plugging it back into the first equation,
6.
x plus 2 times 2 equals 10, which gives me x plus 4 equals 10. Subtract 4 from both sides, and as Jordan was way ahead of me there, x equals 6. So I write this as a coordinate point 6, comma 2. You guys think you can handle this?
No.
If I give you some lines that have nice integer answers, letting the lady come up there. Okay, so I'll give you some relatively simple lines, but for your homework tonight, forget what's on the study guide. I'm changing it since I was out the last couple days. And I will quickly get you some new lines that all have fairly reasonable answers. And I want you to do this all 3 ways. Think you can handle it?
For everyone.
Yep. So I'm only going to give you like 4.
Yay.
So we'll do
12. Yeah, 12 methods.
Yeah.
Okay?
Say bye.
Yes. Okay, and cut.